I'm Isaac Held. I'm the recipient of the BBVA Frontiers of Knowledge award in the climate change category.
How have you received the news that you had been awarded the BBVA Foundation Frontiers of Knowledge Award?
I received notification of the award this morning by telephone call from the foundation in Spain, and it was a great surprise because I didn't even know that I was nominated for the award.
You have studied the physical causes that distinguish climate differences around the globe. What do we know with certainty about the evolution of those patterns as a consequence of climate change?
Certainty is a word we don't often use in climate science, but we have higher or lower confidence in various aspects of the climate change problem. But there are many things we're quite certain of. For example, that the carbon dioxide content of the atmosphere is increasing, and that increase is due to primarily fossil fuel combustion. And we are certain that CO2 is a greenhouse gas that warms the atmosphere. And we're very confident that the effect of that increased CO2 in the atmosphere has resulted in a warming of the Earth of approximately 1 degree centigrade over the past century.
Your work distinguishes itself for including the role of water in climate change. What does that role entail? How does it manifest?
Water interacts with the climate and is influenced by other aspects of the climate in a multitude of ways. And one important way that it affects climate change is that it acts as a positive feedback because water vapor is itself a greenhouse gas. So when you increase, for example, the carbon dioxide content of the atmosphere and the atmosphere warms, that warmer atmosphere holds more water vapor, which increases the total greenhouse gas content of the atmosphere, and it warms the atmosphere even more. And that's one of the aspects of the problem that I've studied, this feedback effect of water. But of course we're interested in water also because of the way rainfall is distributed over the Earth's surface, and we're concerned about how that may change in the future. One region that I've looked at quite a bit in my own research are the factors that govern the rainfall in the subtropical or Mediterranean areas, such as Southern Europe and North Africa, and the mechanisms that might be responsible for drying that region in the future over the next century in particular.
Okay, same question now, basically. You've covered it.
Okay.
Your studies forecast an important climate change in the area of the Mediterranean Sea. What will this change entail, and what magnitude can it be expected to have?
I think we're uncertain about the magnitude of the warming that we expect from increasing greenhouse gases. That's unfortunate, but we have to live with that uncertainty because it's primarily due to our lack of understanding of how the cloud distribution over the Earth's surface is going to change. And that's turned out to be a very recalcitrant, difficult problem. But if we assume a certain amount of warming, in a typical climate model may predict on the order of 3 degrees warming over the next century if we don't curtail greenhouse gas emissions significantly. And work that I've done with theory of climate and computer climate models suggests that in Mediterranean areas, you might expect on the order of 5 to 10% decrease in precipitation per degree centigrade warming in climate. So we could easily get a 20% reduction in rainfall over the century due to increasing carbon dioxide in the atmosphere. Yes, I'd like to thank everyone at the BBVA Foundation who was involved in the selection process, and the foundation itself for being so generous. And I think there are many people in the climate science who are equally qualified to receive this award, so I feel very honored. Even to be nominated for an award like this is an honor, but to receive it is quite unreal for me, and thank you again.